Well, hi, good morning. Thanks so much for joining me here in my shop. Today I think I'm going to run through the alignment process on this radio. This will be the first time through for me. I've looked it over briefly. It's a pretty complicated affair. So I'm going to go through it. I'm not trying to get the radio perfected at this point. I'm more interested in learning about the alignment process and practicing it for the eventual final alignment when that comes, and along the way I'm liable to discover more problems with the radio. I wouldn't be surprised if there's still some more problems with it. So I think this clearly is going to start with reading the alignment process. So I'm going to study up on that, and then we'll look at it together on the computer screen. Okay, I'm going to read through this. I've read through it once. I'm going to read through it again. It's got lots of interesting and important stuff in it, but you know, you might not want to listen to me read this. Just skip ahead in the video a little bit. So here we go. Alignment procedure. There are various alignment trimmers provided in the detector and oscillator coil tuned circuits. If the IF transformer adjustments are made by means of screws, the IF transformer adjustments are made by means of screws attached to molded magnetite cores. All of these circuits have been accurately adjusted during manufacture and should remain properly aligned unless affected by abnormal conditions or altered during service, or how about if it's the next century? Because that's the case here. Loss of sensitivity, improper tone quality, poor selectivity are the usual indications of improper alignment. The loss of sensitivity, the way you compensate for that spontaneously is you just turn the volume up higher. You may be less aware that in fact the radio is becoming insensitive, but what would come along with that is a little more noise. The correct performance of this receiver can only be obtained when the aligning has been done with adequate and reliable apparatus, and it's certainly the case in my shop here in 2020. It is not necessary to use a frequency modulated oscillator and cathode ray oscilloscope to align this receiver. Those service people that have this equipment will probably prefer to use it, and for their convenience we have indicated on the trimmer location diagram the proper connection point for the cathode ray vertical amplifier input terminal. You know, one of the things I love about these old write-ups and lots of old technical writing and technical books and that is the writers spare no use of language to get their point across. They use all the words required, so a small point can take a whole paragraph. I like that. What they're doing is they're making sure that the reader gets it. They're not counting on the reader to reread their paragraphs 5 times. Although, you know what, I'm going to reread these 5 times. A test oscillator is required as a source of the specific alignment frequencies. Visual indication of receiver output during the alignment is necessary and should be accomplished by the use of an indicator or meter. So they're not being quite direct here, but they're saying hook up your output meter to the voice coil terminals on the speaker, which of course we don't have a speaker here. But I have a way of doing this, no problem at all. Procedure outlined below should be followed in adjusting various trimmers and capacitors of molded cores. Calibrate the tuning. Oh, here we go. Calibrate the tuning dial. That's the number one thing we got to do. Calibrate the tuning dial by adjusting the pointer to the low frequency end of the scale with gain condenser plates fully meshed. The pointer may be adjusted along the phosphor bronze drive cable by slackening the stud which secures the glider to the phosphor bronze drive cable. That's step 1. Make sure the pointer's on the cable in the proper spot. Perform alignment in proper order as shown by the accompanying chart. Here's the chart. And follow all operations across, then number 2, etc. The chassis bottom shield must be securely in place when making RF adjustments. So this is a bit of a problem. At this point in the whole process, the bottom shield will not be on because I want the bottom exposed yet. But in the final adjustment, I have to have this plate on. Adjustment to locations and frequencies are shown on a sticker fastened to the bottom of the chassis shield. Well, how you like that? Yes, there is something down here. I'll stick it on the camera in a moment. That's kind of handy. These terminal locations are also shown on one of the accompanying illustrations. Connect the low or output terminal. Connect the low output terminal of the. Oh, that's careful. Careful, Jim. Don't read that wrong. Connect the low output terminal of the test oscillator to the chassis for all alignment operations. Regulate the output of the test oscillators so that minimum signal is applied to the receiver to obtain an observable output indication. This will avoid ABC action. Now, I thought a lot about this, and I'm thinking there's a little more to be said about this. The one thing is, if you're not paying attention to what's happening with the ABC, you could easily overdrive the front end of the radio, or the radio generally, with too much signal from your signal generator. So you need some kind of indication that you have got enough and not too much. One way is to go for the minimum. So you turn the thing down until your signal generator down until you're hearing noise kind of coming from the radio. Then you can be assured you aren't blasting a whopper signal through there. So I think that's part of why they're saying this. The other thing I'm thinking about, this is just my head, this will avoid ABC action, but normally when the radio is operating, you're tuning to signals that bring up the ABC voltage. Wouldn't you rather have the radio aligned for some amount of ABC voltage in it? And lastly, a good radio is not going to be affected by its ABC. It's not going to cause a drift or something like that as the ABC goes up and down. So is there something more? Maybe there's something a little more here that I just don't quite get, but I do follow this procedure. Okay, this is an interesting paragraph here too, because a bugaboo with me is this term dummy antenna, which I think is a dummy term, and it makes us all dummies. So here the engineer who wrote this took the time to explain what he means when he says dummy antenna. The term dummy antenna means the device which must be connected between the high test oscillator output terminal and the point of connection to the receiver in order to obtain ideal alignment. So all he's saying is you can't just hook up your test oscillator to this radio and align it. You need to have something in there, maybe a capacitor or resistor, maybe a capacitor and resistor. And there is a standard, I hate to use the word, dummy antenna. I would rather use the term interfacial circuit. Or, as my own device actually is called, antenna simulator is what it's called. I'll show it to you in a bit if I can remember to do that. So that's what this dummy antenna thing is. It's just a dummy term. Now, in my mind, a real dummy antenna is a 50 ohm resistor stuck on the back of a ham radio, a high wattage 50 ohm resistor. That to me is a dummy antenna. But anyway, moving on. Here's another one. The term rock through indicates the receiver station selector should be rocked back and forth while making the indicated adjustment. The adjustment and rocking should be continued until the combined action results in the maximum deflection on the output meter. So this is a little bit of a better description of the rock through process, which I almost never get to work for me. It has worked really only in one case that I can think of, a small radio, and clearly I could rock my way into a very, very sensitive spot in that radio. But other than that one, this just has never worked for me. What is really going on here is there's an attempt to align 3 different things at once. So the only way to do that is to move 2 of them to match the third. And that's really what's happening here, as I've come to realize after thinking about it for so many years. So there are other ways to make sure the 3 things are lined up and not use this rock through technique here in the year 2020. Okay, when adjusting oscillator circuits that have both series and shunt trimmers, it's a good practice to repeat the adjustment on the oscillator shunt trimmer after making adjustment on the series trimmer. Now, how do we know which ones are shunt and which ones are series? We gotta study the schematic and everything. I would imagine the alignment chart down here has things in the proper order. And why the engineer wanted to put this in his instructions, I don't know, but he did. Thank you. When calibrating the shortwave spread bands, it is necessary to have a very accurate source of test signal. Now think about it, back in the day, nobody had digital frequency counters and stuff like that, it was very, very hard to know if you're right on frequency, and they give you a hint on how you can do it here. As there are no service oscillators available at present, maybe 1937, with sufficient accuracy for this calibration adjustment, it is recommended that the respective adjustments to these things be made while listening to a shortwave broadcasting station of known frequency, approximately in the middle of the band being calibrated. So, of course, today in 2020, I've got equipment that will tell me exactly what frequency I've got my equipment running at, so this isn't an issue. Operations 7 and 8 may be performed after Operation 6 by setting the receiver to 11800 and tuning the test oscillator to the receiver. So what they're saying is, once you get the first band aligned, you can then use that band to align your oscillator to carry on with other alignment activities. That's what they're saying here. And this is another thing the engineers put on here. I'm not exactly sure why, but if you were doing major work to this radio, you'd have to pay attention to these things. But these are more manufacturing type issues. Precautionary lead dress. And there's interesting stuff to realize here. All bare bus leads adjacent to RF coils or range selector switch should be as short and direct as possible. All insulated leads, all insulated leads adjacent to the RF coils should be dressed away from the coils. All insulated leads. All bare bus leads. I never really thought of these two things as being dramatically different. I usually think of the bare wires as going to the chassis or going to ground, and that's why they didn't bother paying for insulation on them. Am I a little wrong about that? And insulated leads adjacent to RF coils should be dressed away from the coils. So all this will be done during manufacture. Now I changed a number of capacitors. I tried to keep them all in the same position they are in, but not quite. Heater leads should be tightly twisted together and dressed away from grid leads of audio tubes to avoid hum pickup. So one grid lead in this radio, where the tube has been substituted, has been relocated from one side of the tube socket to the other side, and has gone from being pretty much against the chassis to being up in the air a little bit, but it is shielded. But it's also gone from going through a hole up to a grid cap at the top with a lot more lead wire to a shortened wire going to this new terminal. Did any of that cause hum pickup? I don't know yet. Don't really know. While I'm working on this radio in my shop, I'm using a fairly small speaker, a little like 3-inch speaker. It's not going to reproduce the hum properly. If there is a hum in the set, I don't know it yet. Leads connected to phonograph pickup terminal should be tightly twisted together and dressed close to the chassis frame, which they are. Power output stage grid leads. Power output stage grid leads should be dressed away from the high voltage secondary winding leads of the power transformer to avoid hum pickup. So of course, when you think about the radio, you have all those wires and parts in there, and many of them have oscillating frequencies inside them. In some cases there's heavy currents involved, so relatively heavy currents involved. You get stronger magnetic influences coming from the wires that are carrying the heavier currents. So an example would be output of the IF, plate circuit of the output of the IF, stages. Somewhere in there you may have heavier currents carrying the IF frequency, or in this case you're talking about the power transformer with strong 60 cycle currents in it. So all these things are taken care of with the radio design, and we just have to keep them in mind when we're doing work on these radios. Generally I don't though. So here's the chart. We'll just look through the chart quick, way down to the bottom here. 1 star. If 2 peaks obtained, use higher capacity settings. So in the case of a capacitor, they'd be clamped down tighter. If 2 peaks obtainable, you have to go looking for them. If 2 peaks obtainable, you could pick 1 peak only knowing that there's one and it's the wrong one. If 2 peaks obtainable, use lower capacity settings, so this is more open. If 2 peaks obtainable, use lower inductance setting, screw further out. Okay, got it. Now, alignment chart. Order of alignment, 17 things. Oh my gosh. Connection, where are you connecting it? Okay. Test oscillator, dummy antenna. Here's what they're recommending. The output of most test equipment is 50 ohms. Most antennas, like a wire antenna hanging in the sky, is 300, 400. Most other antennas are 100, something like that. Maybe a couple hundred. So to look like an antenna, you have to do something to your test equipment, and that's what this is. Make the radio think it's hooked up to an antenna. Frequency setting. Okay, so 460 is the eye of frequency. Boom, boom, boom. 3 of them here. 3 at this frequency. Range setting. Well, an awful lot gets done on this 11 megahertz band. We're doing the broadcast band at the end. Not the beginning, but at the end. Is that right? No. Oh, yeah. Well, it's saying here, when you're doing the IF, it's hinting because of this that you're on the receiver dial and range setting. Well, you're in the broadcast band while you're doing these. First detector. Cap, manual. Second, first, second. What? Wait a minute. Ooh, back here. Step 3, do the second. Step 4, do the first. That's how things work. Step 5. So you're moving this. You've moved it here. So step 1 is done with this on the grid cap. Step 2 is done with this moved. Oops. Okay. And it's L2324, 2324. Okay, that's just a little unusual. And we're going down here 3 times on the on this band, 1, 1, 1, and then we're getting into the antenna, the tuning for the AM band, for the broadcast band. Rock through. Oh, so where's all these stars here? So there's that. So all kinds of them are getting multiple peaks, or potentially multiple peaks that you have to look out for. Repeat. See instructions below for AFC alignment. So we're going to look through those too. I'm going to get the whole thing kind of in my head here. Yikes. Oh my gosh, this is an awful lot of stuff here. Shortwave calibration. This looks like a bulletin. We have found, okay, it's a bulletin. We have found during shipment, it is possible for the oscillator control grid lead in these receivers to shift sufficiently to throw the shortwave dial scales somewhat out of calibration. The grid lead position is that important? Wow. You think if you're shaking a radio enough to cause this wire to move, you'd be moving a lot of other stuff. When this occurs, the calibration on all shortwave bands will usually be found to have shifted in the same direction. That is, all 4 dial scales will be high, or all 4 dial scales will be low. If such a condition is found, it will be a simple matter to correct it by rotating the oscillator control grid clip so as to change the position of the flexible lead, checking the calibration of shortwave bands while this is being done until the calibration is accurate within 5 kilocycles. Anything else about that radio? No. Oh, here's something. Calibration shift on standard broadcast band. Oh, this is the same thing again. This may be due to imperfect contact. Oh, it's something different. This may be due to imperfect contact of the wire lead to the molded, you spell molded in a couple of different ways in this, molded frame of one of the air dielectric trimmers. This condition may be corrected by soldering. 49 meter band. Calibration shift. What do they mean by that exactly? Calibration shift. imperfect contact. So maybe what they're saying is it's some kind of what do you call it? Come and go type problem, or you know, bang the radio and things shift a little bit. Maybe that's what this is. Right to my soldering. Any more on this? Relay bending tool. Yikes, that's for another radio. Yeah, this is all another radio. So I think that's the whole story looked over. Here's a guide showing where all the adjustment points are. There's a lot of stuff to do. So you know what, today if I just get through the IF alignment, then that's pretty good in itself. Very first thing we need to do though is set the pointer, check the pointer. It's probably correct, but let's check it. Okay, that's enough of this. Okay, checking the pointer. Now when radios are on their sides, the pointers tend to hang. This one's not bad at all because it's got this incredible apparatus up here. But a lot of radios, you put them on the side and the pointer will droop. Not this one. In fact, it looks like it's kind of bent upwards, doesn't it? So it's hockey stick right here, right here. Now if I bend this too much, it'll crack the paint, maybe. Oh, that's a really stiff piece of metal. Wow, that's a real springy piece. There we are, straight now. And we take it to, let me just make sure I'm reading the instructions here properly, because that would be too bad. Adjust the pointer low frequency end of the scale. Condenser fully meshed. Low end of the scale. Condenser fully meshed. I'm watching the. Ooh, what was that? What was that? What's that? What's happening right there? So there's a knot going over this pulley right here. That's what I'm feeling. Right to the end. Oh my gosh, it's right off the scale, isn't it? Or is it? And where exactly? The pointer may be adjusted along the oh yeah. Calibrate the tuning dial by adjusting the pointer to the low end of the frequency scale. Low end of the frequency scale. Well, I mean, it's got to be just the end of the scale here. Now we get a chance to look at this pointer too. Ooh, the whole thing is way off, isn't it? So it just looks like it's bent right in here, and it's just going down. I'll try bending it up a bit. Let's get the parallax problem solved here. Make good use of my camera. Now I'm just checking the level here. Okay. Well, doesn't that look good? That looks pretty good. Funny, but the bottom scale actually is a touch short, isn't it? It's not the pointer. Okay, number one step done. Excellent. Good. Great. On a phosphor cable. Good, so I leave that alone. Next step is number one, turn this screw all the way out. I kind of skipped over those two things. I'm going to go back, I'm going to put this back on the screen for a second here. So for some reason when I looked at this, I skipped 1 and 2. Maybe because the boxes were small here, I got caught on this. Look at this, number one, turn this screw all the way out. AFC IF L26. Check with mechanics scale. This screw, wow, I ever missed something interesting here. Check with mechanics scale. This screw should protrude exactly 1/4 of an inch. So then that's our next step here. L26 and L25. And where are they? L26 and L25. C. Well, come on. Huh? L26 and L25. it's one of these cans. I'm sure. I think it's this one. It's got 1, 2, and 3 on it. I think it's number 3. And oh, come on, they didn't number them. 3. L26. Well, this is kind of a drag. Wait a minute, now there's something on. They said there was a thing on the bottom of the bottom. A thing on the bottom of the bottom. Let's take a look at that thing. Okay, here it is. This is the bottom of the radio. What do you say? That looks exactly like the. No, it's not exactly like the diagram. Cathode ray oscillograph vertical high connection here. So this is the audio. This is the phono input here, and you're just watching right there. This is basically where the audio is just coming out of the detector. Did not put numbers on here. Someone has penciled it up a little bit. X has got an X right beside there, and that looks like an X there too. Well, this is going to help because it doesn't give the labels. Oh, really? Is there anybody writing these secret notes on this panel? Look at these weird scratch marks. No, it's just from being slid around on surfaces. I'm pretty sure that's all that is. There might be some, secret message like "Help me, help me." Where are those guys then? So I have no idea where they are. Let's go back and look at that manual some more. So there's some coil numbers there. Now, it wasn't. Let me look again. I think just to be sure, it's 25 and 26. 25 and 26. Figure out from here. 25. There it is. 25 and 26. And this is considered the third. 1, 2, 3. It's noted as the third IF. So the third IF. This is just incredible. It takes so long to be sure of things, but you need to be sure. This is what this is all about this time through, is getting sure of all this stuff. Third IF is this one. So it's the 2 screws. Now one is 25 and the other's 26. Which is which? Does it say? Here they're talking about 25 again. Well, wow. 26, 25, and 26. They don't say though which is which. Is it the top one or the bottom one? You must tell me. Hint here. 25 and 26. First. Second and third. Those numbers don't appear, 25 or 26. They don't even appear. Oh. Here's something. This is a little bit more helpful. So here's 26. And there's 25 on the secondary side. And there's a core in 27? No. Oh, look. Top, bottom, top, bottom. Do you think that's where they hid this little piece of information? And what is this funny looking thing? What is that? It's like a pair of pants or something. I don't know. That's the grid. I think that's the shielded grid connection. I don't know what that is. Okay, so that's got to be the hint. Now, how do I know this is the top? Because of the way the words are written. Yeah, in fact, this whole thing should actually be like this. What else have we got to go on? Top and bottom. So 26 is top. This is critical stuff here. 26 is top. So if one of these is adjusted correctly, it'll be exactly 1/4 inch sticking out. So that'll help too. Okay, so I know which can it is, and I know what I'm looking for. I think sort of. Let's go back here. Just before I leave this. .25 is the 1/4 inch. 25. Oh, let's go look at the radio here. Okay. So number 3. I'm already laughing. Here's number 3. 1/4 inch from the top of this can. It's barely sticking out. From the top of the can, or do we pull the top off and measure it inside? Okay, so on the bottom, this one's sticking out 1/4 inch. Oh my gosh, how are you ever going to even measure that? I gotta change cameras here. This is ridiculous. Wait a minute, it's 1/4 inch to start. It's 1/4 inch to start. So you set it to the 1/4 inch, but then there's a long alignment process involving these same two coils. So maybe you start at 1/4 inch, but you don't end up there. So it says use a very accurate meter to do this. So that's definitely not sticking out at anything 1/4 inch. And this is not sticking out in any way 1/4 inch. It didn't help with the hoot. You pop these tops off. This whole, you know what? This could have been the whole thing I was chasing all that time in the radio. Why it didn't work? Because these are plug-in modules. I haven't tried unplugging them or anything. I didn't even try doing this. You know, they might be bad contacts all down here. I've never seen plug-in. That's what they plug into. Never seen plug-in. And those metal things sticking through there. That's the mechanical hold down that's being used. So you just pull hard on these cans, they'll come right up and out. I mean, they probably figured that, you know, somewhere around about the year 2020, they'd need to change these cans, so they better make them unpluggable. You know? Okay, where are we at with this then? I still don't know which coil is which. Right. So I'm not sure how to set this up for the starting point. Well, I got the pointer right on the dial. What about this? I'm going to stop for a while and review all the documentation and try to find a hint on this. Okay, so on the alignment chart, the screw that's supposed to be out 1/4 inch is L25. And from up here, I can figure out that L25 is the bottom slug. So that's the one that's under the radio. Now, how can you do this with the bottom plate on? Make sure the bottom plate's on. I mean, right away, you cannot do this process. All those engineers. Okay, so we're going to look at the bottom one. That one's a little more sensible in terms of measurement. Look at the top one though. Turn it all the way out to start. Okay, I'm going to have to do this. 1/4 inch on the bottom, all the way out on the top. Quarter inch on the bottom. So the way I'm going to do this, I'm going to use a caliper for verifying the measurements here. Whoops. Nothing bad happened there. Okay. I'm going to try to use this. So number 3 is this one here. Oh my gosh, this is not going to be easy. 1/4 inch. Yeah, I can do it like this. I can do it. I just need to make this a 1/4 inch. 1/4 inch. I don't think I have a precise ruler in here. I gotta go find myself a good ruler for this. Okay, first step is set this to a 1/4 inch. I have a ruler down here. It's not exactly a mechanics ruler, but 1/4 inch. Okay, so the points on my gizmo here are 1/4 inch apart. I need a screwdriver. Very uncomfortable with doing this. Because my assumption is this has been aligned properly initially, and I'm about to, who knows what I'm about to do to it. Got to come up quite a ways. This is definitely number 3. It's locking up. And a couple turns easy there. Trouble getting the lighting right for the camera. Ooh. Consistent resistance. That's good. If it was getting tighter and tighter, I'd be worried. It's getting tighter and tighter now. I apologize for that bang just now. I know my bench is very noisy with the microphone arrangement, so thinking about how to solve that, and one thing for sure is not throw the tools on the bench anymore. Oh my gosh. Well, what if you can't do this without thinking you're going to ruin something? This is always the kind of stuff you run into with these radios. So I'm going to back it in and then come out again and see if it loosens up that way. Screwdriver keeps camming out of it. Just being muscular with it now. Ooh, it's really, really sticky. You ever wonder what it's like just before things go terribly wrong? So you can think about the slug in there is dragging on the inside of the form. That's what I'm working against. If it drags hard enough, then when I turn the screw, I'm twisting the form inside there and getting close to damaging something. Who knows how strong these things are inside? How rugged they are? Pretty rugged. Because they have to take this on the assembly line. Jeepers creepers. Why those? Probably the slot here has been bent and deformed a little bit. No, it's not so. I got farther to go. These coils too. I mean, really, if you now it's loosened right up. Now it feels really quite loose. Is that a good thing? I think. Oh, it's really loose. I think that's a good thing. Did somebody come in and tighten all these down? The last radio, a little radio I did, a thing like this, somebody had tightened it right down, and basically killed the radio. Could that have happened again? Because we're getting pretty close now. In fact, you could call that a 1/4 inch. You could call that. Assuming it's above the... sticking out a 1/4 inch. I can't imagine how you would call that anything else. And then the other one, it's supposed to be backed. It's at all the way out. What does that mean? All the way till you're scared to turn it further. That's it. I'm scared to turn it past that point. It's pretty loose and I tighten right up. So is that out where it's supposed to be now? Should I push past that? A little bit. Let's try a little bit. I can get away with a little bit of dangerous behavior here. You know, it just locks up in the same spot every time. So that's it. I'm not putting that one any further. Wow. I just messed the whole radio up. This whole automatic frequency thing, you must have it switched off when you're doing the alignment. And I don't remember reading anywhere about that. Making sure it's switched off. So you kind of think these adjustments can't have much effect up here if this feature is turned off. Wait a minute. Turned off means shorted. That's right. Off looks like on. And it didn't mention it anywhere. Did I miss something? Is there another table of statements I missed? Again, that's why I do these alignments the first time through. I'm really not intent on being terribly successful with it. Okay, so we have that done. That's step 1 and 2. Oh, I've got a cat here. That's a good time to stop and take a little break. I'll go and play with my kitty cat. Hey, Peanut, come through the door. Peanut. Ta-ta-ta-ta, there he is. Yes. Okay, so weather today here is terrible. Rain all day, very high winds, dangerously high winds coming, and then that's going to change tomorrow to snow with a potential of a large amount of snow tomorrow. So a huge change in the weather around here. And by the way, if you look out in the hall there in my house, you'll see a radio up against the wall there. That radio is the one I did a couple of weeks ago. That is a very similar radio to the one that's on my bench right now. Very, very similar. I think this one is 1 or 2 years older than the one out in the hall there. Now, I see my cat now he's indicating where he wants to go. Peanut, you want to go upstairs? You want to go in the garage? What do you want to do? I won't use the O-U-T-S-I-D-E word. As much as I believe cats can't understand words at all, I'm going to avoid it. Okay, break time, break time. Ooh, I have a tough time peeling myself away from the TV these days. So, I think I'm just about ready to go here. So I was in the middle of doing some camera experiments there, checking the focus on my cameras. Okay, which is equally poor in all cases. Let's get this radio operating and warming up. Okay, heater's on. Okay, saw a light come on up here, that's good. So what I've got hooked up here, this is the audio takeoff. It's going to come out of the speaker if we care to listen to it. There we go. I've got this output meter. It's connected to where it said in the manual. You can see the wires kind of disappearing through a hole here. It's just to make easy clips to the terminals there. The audio is available at this point, so I guess it's a good reason to put it there. This point is before the volume control, pretty sure. So what we're listening to is after the volume control. But this guy is going to monitor before the volume control, I think. Okay, now we're ready to start raising the B+. Let's make sure we got some audio down here. Here's something if it comes. I mentioned earlier there was DC in this control. I think it's being supplied by my amplifier here. I wouldn't be surprised. Because the radio shouldn't be making that kind of noise. There's no B plus in it yet. Okay. So we'll be able to crank up the B plus, and we should hear, let me move the camera over here. We should hear, let me actually douse the lights. We should hear the radio come to life. This is my hope. Here we go. Turn it on first. Is this behaving normally? Watching the current up here. 25 milliamps, about 100 volts. Usually we hear it. I'm a little worried that the meter connection, let's see, no, the ground is to the ground here. Why are we not hearing anything? Oh no. I'm back to where I was before. No. Oh my gosh, there's not a sound coming out of it. Who is messing up here? Let's make sure my speakers. Yep. Speaker working. Volume up. Oh, maybe I didn't have the volume high enough. Oh, the other thing is I don't have the signal hooked up yet. I'm a better antenna than that little clip lead. How good an antenna am I? Not very good. Not very good. Okay. So I'm going to turn this down. Good show. I think everything's working. And we're going to attach this to the grid cap of the 6K7IF amplifier, which I have a capacitor. Oh my gosh. And you know, that tube is probably supposed to be clad in metal. It's probably not supposed to be like that. And I'll bet you before I'm done, I'm changing that tube with a metal one. Because that's not too good. Okay, let's hook this up now. What should I do? Turn down the volume. That would be a good idea. Hook her up. Turn it up. Okay, sounds good. Doesn't sound distorted. I'm putting, I don't know what I'm putting in there. What I'm putting in there. 100 times 10, about 1,000 microvolts. About a millivolt. Okay, and I'm using the IF frequency, what should be the IF frequency. Let's vary this thing a little bit and just see what happens. Very good. So I watch the output meter here and set this to max. Right about there. Look at that, 459. It couldn't be any more accurate on my counter there. 460 is what it actually was. Excellent. So it's tuned properly. Or so it appears. Let's see if we can mess this up. So I want to do the second IF. I can arrange this just nicely here. About like that. That's not so good. I got to step in front of the camera here. Let's put this like this. Put that like that. Here we go. Now, we're at 460 for sure. And we're going to try, I'm going to tap it with a metal screwdriver. So we want to do number 2. This is number 2 up here. Tapping. Doesn't seem to do anything. I have a top and a bottom. I have the feeling my screwdriver is too big. No, it's going in there. But I don't like it. I'm going to use this one. And I definitely need more light on the topic here for me. Okay, objective is make that meter go up. Right on the money. Okay, we'll try the top. Where is it? It's down in the hole there. Okay, I'm on the slug, watching the meter now. Down, down. So this is perfectly tuned. Okay, so that's all we can do at this point. We're going to move the injection point to somewhere else on the radio and do the next. I think I'm just moving it back to here, am I? Let me find out here. I can turn this down so we're not listening to it so much. Right. Check the instructions here. Okay, so it's just a matter of moving the clip lead to the 6L7, which is here. Okay, take off the signal generator. Take off this. I turned the volume down so you're not hearing a huge hum there. And we go on here. All these leads I'm going to be changing. I haven't changed them yet, all the grid leads. That's going to throw all this off. Where are you going? I really want to hang on there. Very good. Okay, that's a little better. Take this guy. I want this to be grounded. Go right on this plate. Knock down the input here by a factor of 10. So that meter jump. What do we hear? Very, very faint. Now I did knock down the input signal. Okay. I think I should just tune that transformer. This one right here. Check for sensitivity here. Nothing. Okay. Oh, look at that. So this is obviously affecting it. That's really affecting it. So is everything being done right here? Why would one transformer be perfect and the other one be way out? Again, my objective here is not to get this perfect. Let's volume down a little bit. And cut back the signal here a little bit. I have my hand and my fingers on there. Let's get a different tool here, because just bringing my hand up. Is that moving the meter? Yeah, just moving my hand up and down. Yikes. Okay, let's go way out here. Problem with this plastic. There we are. found a new problem with these plastic things is, see how much twist I'm putting into it? And it's not moving? And then all of a sudden this will break free and it'll jump. And that's why I like to use the stiff tools. Wow, that's really tough to turn. Big difference there. That was substantial. One perfect and the other one not. Okay, get underneath here. It's a good place to use a plastic tool, that's for sure. Okay, I think I'm coming in now. There we are. Okay, watching the meter again. Gee. Let me turn down the input signal. So there's the peak. Well, we got a chunk out of that. Is that just because one of these grid wires has been moved a little bit from when it was originally aligned? That's good though. So what we should do at this point is check the receiver for reception. Since we made a bit of an improvement here, turn the volume down, take this guy off here. Yikes, 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 don't go flying, don't go flying. Don't go flying clip leads, please. Now it doesn't want to come off. There we go. So all we need to do is put an antenna on it and start listening. Okay. Antenna connection. Keep your eye on that meter. Ground I'm going to leave off for a moment. Spin this around and around and around we go. Incidentally, I changed the injection point for the B plus down to the very initial point at which B plus enters the radio normally from its own power supply. Where I had it up here, I think that's just a little different, a little bit too different. I want it to be as close to normal operation, right? The regular power supply is not operating this radio. And just checking that, still 25 milliamps and some B plus. Okay. Not much happening there. I'm pretty sure the antenna is switched off right now, so I gotta run, like I seem to do every video, run down and throw a switch. Okay, here we go. What's wrong about that? Unfortunately, the antenna is live here. Volume up here. Maybe I didn't have it. Oh no, it's turned up full on the radio. Well, that's a kind of a disappointing deal, but not to pay too much attention to it. I think I just did the whole thing on the wrong band too. I'm supposed to do this on the broadcast band, and I did it on the wrong band. And that's why I don't really expect much out of myself during the first alignment. Okay, let's move bands here and volume down. Okay, now we're on the broadcast band and I can hear stuff. There's some DC voltage affecting this meter right now. The AVC could be on it, and you're not seeing it very well here. because it's actually like this is not 0. Okay? This is now 1 volt. This is 10 volts. There's never a 0 on this meter. It's more than 10 volts there, and there's really no sound. That's kind of making this measurement a little bit crazy, so we'll just kind of ignore this meter for now. Besides, we're just going to tune the radio and see what we get. I'm going to put the antenna ground on. It's a little better, I think.
Now, the only math he's doing is this. 3345 and 655 is no student should have to learn this and go back to school. Donate to Pathways to Education to help youth in low-income communities continue high school. We are Toronto's news talk leader.
Wedding receptions are going to be banned. You can't even go to somebody's backyard in Peel.
640 Toronto is where the biggest names come to talk.
Mayor of Brampton, Patrick Brown.
And for those in decision-making in Ottawa, I'll repeat this for the 3rd time. We need an isolation center. Nothing will make a bigger difference.
Tuning off a little bit.
9 a.m.
I'm trying the automatic frequency control here. Tune it back in. No action whatsoever. Leave it in the ground position. What else can we get? 680. Good test up here. The French station right up in here. Oh. That's pretty good. Tone controls just seem to do nothing, but I have a small speaker here. The volume is all fake because of the way I'm doing this, so it doesn't mean anything. Very good. Okay, I'm happy with that. This says to me continue on, but I'm not going to continue on today. I'm done for today. What is the question? So tomorrow I will continue on with the alignment. We probably won't get through the whole process again because I'm in that initial learn how to do it, make all the mistakes now process. Very good. Okay, so thanks a lot for watching, and we're making progress here bit by bit.